What is a function? The definition of a function is that for each input value, often x, there can be only one output value, often y. This relationship between the variables can be described and visualized in different ways, such as algebraic expressions, a table of values, or as a graph. To get started, let's look at how functions work. You can think of functions as machines. You put something in and get something out. Let's look at an example of a function machine. Say you input the number 1 into the machine, and it outputs 2. Next, you input 2, and the machine outputs the number 4. Then you input the number 3, and the output is the number 6. What happens if you input 4? It gives you 8. It seems like the way this particular machine works is to double the numbers you input. 2 times 1 equals 2, 2 times 2 equals 4, 2 times 3 equals 6, and 2 times 4 is 8. Before diving into how you formulate what the machine did using math, let's first look at some theory. In mathematical terms, this machine is called a function. Usually, you use x as the name for the variable you input. This is known as the independent variable because you choose the values. It's called a variable because it doesn't have to be the same value all the time. In our example, you went through the values 1, 2, 3, and 4. What the function outputs is dependent on the value of the variable you input. So the output value is known as the dependent variable. The dependent variables in this example were 2, 4, 6, and 8. To indicate that the function is dependent on the independent variable, you write the letter f followed by x inside parentheses like this. This is read as f of x. The letter f is often used because it stands for function. If you have more than one function, you just continue naming them after the letters of the alphabet, such as g of x, h of x, I of x, and so on. A function's expression often looks like an equation, where the left side of the equal sign is the name f of x, and the right side is the mathematical formula that produces the output. So, back to our example. You now know that the function will be named f of x. Since this machine doubles the numbers you input, you can write the mathematical formula for the output as 2 times x. So this function's expression is f of x equals 2x. In this case, 2x is the formula that describes what the function does. This is known as a function's expression. The expression describes the relationship between the number you input and the number that the function then outputs. For example, if you input the number 4, you write it as follows. F of 4 equals 2 times 4, which equals 8. Great job! You've just used math to describe this function. Next, you can organize the input values and their corresponding output values into a table, like this. This is a function table, and it's another way of visualizing the relationship between the variables in a function. A function table like this can be used to create a graph, because f of x is actually a y value. The function table illustrates the coordinates of the graph. It's sometimes smart to make a third column to list the coordinates. These coordinates are points in a coordinate system. The x value is on the first, or horizontal, axis, and the y value is on the second, or vertical, axis. First, you plot the points from the function table like this. Then you connect the points. This line is the graph of the function. you can study the graph to see how the values of the function change. This graph is an excellent visualization of how the y values are double the x values. One important thing to note about functions is that every input value has exactly one specific output value. If you come across a graph where an input value has multiple output values, that graph does not represent a function. You can move a vertical line along the x-axis to check whether each value of x has one and only one y value. This is called the vertical line test. Let's take a look at some curves that are not functions. Take this circle. If x equals 1, what is y? You place the vertical line at x equals 1. Notice the line intersecting the graph in two places. Y can be both 1 and 3. But for it to be a function, this is not allowed. So the curve of a circle is not a graph of a function. What about this C-looking curve? Is this a function? Again, you can use the vertical line test to quickly find an x value that gives out two different y values. For example, when x equals 0, y equals 2 and 4. So this is also not a function. Think about it like this. Functions are often used to illustrate the relationship between the price of a product and the cost of buying several products. Wouldn't it be weird if you could buy two identical cell phones for different prices in the same store? So in a practical sense, this is the key idea behind functions. But beware, when you're working with functions, you will often encounter situations where you can input different values but get the same output. In other words, two or more different x values can give you the same y value. If you perform the vertical line test on this graph, the line and the graph intersect at only one point for all values of x. This is completely fine, and it happens all the time. In a practical sense, this is sort of like finding two different items in a store that both cost $2. This is, of course, no problem, and very common. The definition of a function is that for each input value, often x, there can be only one output value, often y.